Hello, everyone. Before we begin today's episode, I'd like to give you one quick little tip in case you are interested in visualizing your own research. Let's say you have already published a couple of papers and you are applying to some academic position. And so there's nothing wrong with, in your CV, including your list of papers such as this. But if you want a more intuitive, beautiful, visual way of presenting that, this kind of a link that takes you to this wonderful image, you might want to use today's sponsor called Litmaps. Their tool is excellent at doing many, many things when it comes to visualizing research. So you can use it to visualize research gap, to visualize particular scientists and their work, and so on. But in this case, you can use it also to represent your own research as a beautiful research map. So here's basically, I used it in 30 seconds working with one of my clients, Edin, to transform his list of publications from this to this. And all I basically did was I took his papers, I uploaded them to Litmaps, and I modified basically how I want this map to look like. So each of these little bubbles is corresponding to, the size of them is corresponding to how much they are cited. And if you go from left to right, that's how recent those papers are. So check out Litmaps. I am the one who reached out to them to sponsor this podcast because I've been using their tool for quite some time in many use cases, and they are just a group of awesome people. Check them out. The link is in the description and in the first comment below. And you might get something off. I forget the number. Like if you do the premium option, you get some percentage off if you use my link down below. So do use that. Thank you all, and let's start with this episode.
All right, everybody. So today I'm speaking with Hana Sahinbegovic. Hana is a postdoc at KU Leuven in Belgium, working on circadian rhythms and obesity on organoids. She did her PhD in cancer biology at University of Ostrava in Czech Republic. And I'm pleased to talk to you today, Hana. Please maybe tell me a little bit more about your academic path, because I see you have a very complex academic path. You've moved around a lot. You've attended multiple universities. You did a double master's. Tell me a little bit, guide me from the beginning to where you are now.
Oh, thanks, George. Well, thank you for having me, first of all. I'm thrilled to be here. I have to say that I was not expecting my life to turn out the way it turned out. Like, I didn't expect to be a scientist or researcher at all. Actually, my first love was music, and I wanted to be a musician. And I was actually training to go to music high school and so on, but I don't know exactly what happened that it turned to, like biology. So in the end, I chose gymnasium, where I met an amazing teacher who just, ignited my love towards cancer, I have to say, mostly. And then I first wanted to be a doctor, let's say, but then the things didn't turn out the way I expected them to. And I ended up studying genetics and bioengineering at International Birch University. And my initial thoughts were like, okay, so I wanted to study medicine, so maybe I can stay here for a while, and if I don't like it, I'm just gonna, switch next year. But I ended up loving it. I really enjoy genetics, and I enjoy reading about cancer and all these techniques and so on. But when I finished my bachelor, I still felt like I just, scratched the surface of the science in general. And I wanted to have more, I don't know, international experience. Yeah. I wanted to see how it is in some universities with, first of all, on history and more budget, because as we both know, about where budget for research is not so easily accessible, let's say, unfortunately. I think it's getting better, but we're still not there. And I ended up going for a master's in Barcelona, and it was just a 1-year master's, which was a little bit short, I have to say. But the reason why I chose this master's was because in the second half, I got to go and do an internship in a research center, and I chose by Hebron center where they worked on cancer, but I specifically did not work in cancer. But I ended up, having my project for the first time, doing all these lab things by yourself and working with cell culture, which was like thrilling for me. But it was just for 6 months, and I felt like, it just wasn't enough. I didn't even think about PhD at that point, but I saw that could possibly be the next step for me. Even though I saw PhD students around me, I saw that some of them were very happy, but some of them were not, that overworried that they had to come during the weekends and and I did that. But I still wanted to do it. And then I ended up applying to DKFZ in Germany. It was like my dream cancer research.
DKFZ being the German Cancer Research Center, which is one of the...
in Heidelberg, exactly.
Mhm.
Yeah, and I really wanted to go there to do my PhD there, but unfortunately, I don't know, I didn't get accepted. I got to summer out and so on. And then I was like unsure of what to do, so I came back to Bosnia to continue my to look for the PhD, but I was not so successful, I have to say. Like, I sent a lot of applications to many different labs, but after rounds and rounds of interview, I would end up not being selected to the labs that I wanted to go. Or like midway, I would realize that this might not be for me. I don't want the research. I don't want the project, so I just ended up turning them down. And I then started my second master's because I was like, okay, I still have time. Like, I could just do another master's. So I finished my second master's in genetics and bioengineering. And then at that point, I got an offer from Ostrava in Czech Republic. I had to say, when I first read about it, I didn't even know where the city was. I had to look it up. And they were actually working on blood cancer. So it's a blood cancer research group. And I ended up talking to them. I really loved the project. So I ended up joining them. And that's where I was for the last 4 years. I graduated in 2023 in October, and I then moved to Brussels and started working in KU Leuven as a postdoc. We're working on a completely different subject, I have to say, but I guess that we can talk about the reason why a little bit later. So yeah, that is my career path.
Sure. Awesome. That's a very diverse set of experiences, lots of moving. Can you tell me a little bit about how was it just moving so much? I know myself in the last 2 years, I moved a couple of times, and at some point it becomes just too much moving. And I remember it was like 2 years ago that I moved, but I was traveling just with my backpack. I wouldn't take any extra luggage because I got so tired of just, I'm moving here. I have no idea where I am anymore. And it was at some point a little bit draining. And always you're adapting to the new culture. You're always meeting new people. It's a new lab, it's a new country, new environment, sometimes a new continent. Tell me a little bit about your experience as an international student in Czech Republic versus in Barcelona versus in Belgium now. How is that for you, that process of adaptation? What was the biggest challenge maybe in being an international student that moved so many times?
Yeah, I definitely feel you. I know it's exhausting, but for me, moving in itself is such a big deal. Although I've never been able to do it with just a backpack, I always have to have two full suitcases. But for me, it's the visa process. I mean, we are from Bosnia and Herzegovina. We're one EU country, and it's always so complicated. And yeah, that can be really exhausting, but I guess you have this purpose, you have this drive, you know why you're going there, and it makes it easier, to just handle that all. And I also have to say that when you're younger and when you have this drive, it's much easier. But yeah, it was from the first moment when I decided to move to Barcelona, I started application for a visa because and it took quite some time. And even when I came to Barcelona, it was really difficult to get an appointment. For example, when you come to this new country, so you have to have your visa before you come to the country, yeah. But afterwards, you have to kind of register in the municipality to get the actual permit to stay there, for those of people that don't know. But to get this appointment can be really challenging, really tricky, and you ended up being a little bit, you feel a little bit labeled there. But it's not just that. You cannot get a bank account. You cannot get a phone number. So this is really like, you have to be really like adaptable. You need to try to find out which company is giving bank accounts without this residence period. It's really sometimes very, very exhausting. And for example, for me, I learned Spanish when I moved to Barcelona because there was no way to communicate to anyone in English, as they don't speak English. So I had to speak in my broken Spanish to the staff and, you know, do complicated things as sign a contract, so open bank accounts. Oh my God. And plus, in Barcelona, they don't really speak just Spanish, they speak Catalan as well. So I think at the beginning, I kind of mixed the two together and, you know, I managed to separate them. But yeah, that was a very interesting experience. And then, for example, now here I have a situation where I had 3 visas, like in Belgium. So yeah, it can be really exhausting, really complicated, real fast. But yeah, you have to be patient and just go with the flow. But of course, there's an upside to it. I really love traveling. I really love learning about new cultures, new places, trying new food. Even going to a supermarket is like an adventure for me to see what they're eating, what they're doing. Oh my God, look at this product. So I really enjoy it. And I also enjoy learning new languages. I also feel like when you learn a new language, you kind of see the way that people think, you know, just some of their phrases that's really like, oh, I get you now, you know? So
Okay.
for me, learning Spanish, learning a little bit of Czech, I mean, we learned this completely, and now learning French and Dutch, it's always an experience, and, you know, I really, really enjoy it. But I think that, you know, I think long term, it's not sustainable, this traveling. I think at some point you just have to stop, you know, and say, okay, I'll be here for at least, I don't know, 5-10 years, because it gets really exhausting. And then, I don't know, if you're planning the family and so on, you have to kind of stay at some place. But I also know that academia in general, they prefer international students. So the more diverse background you have, the more countries you visit, you're kind of more wanted. So even, for example, if you want to do a postdoc, everybody will tell you this, you know, it's not advisable to do your postdoc in the lab that you did your PhD in, because it would be better for you if you were to go to a foreign country, you know. So yeah, there's that component of like, it would be better for you if you were to move, but I understand that it's not for everyone, and that you have to uproot your life. I mean, just seeing your family, like I get to see my family once per year if I'm really lucky, which is really sad when you think about it. So yeah, there are things that are very nice, and then there are things that are not so nice.
Yeah, speaking of the there's several threads I would like to touch upon there. So one is, you know, this moving really does have positive things up to a certain point, and in academia they have this so-called two-body problem. I don't know if you're familiar with that, but just the fact that you have to move so much, and then because you're in academia, many academics meet someone to marry or to be in a relationship with who's also in academia, but then you have two people who have to move around. So they call it the two-body problem, where two bodies need to somehow meet, where it's getting increasingly difficult to get an academic position such as a postdoc, especially a professorship, which is the point where you kind of settle in and that's kind of your long-term life. But now you have to be ready to move somewhere because there's so few positions. But now if your wife or husband is also trying to, you know, playing the same game, the probability is just very small that you'll end up in the same place. So people are always having struggled to navigate with this. I find it interesting that you mentioned visas, because now that I think of it, yes, visas are such a nerve wreck sometimes, because you're always playing with this. I lost you a little bit. You're back. You're always playing with the deadlines that you have to actually come there on time, and you're planning a year ahead. but then
Yeah.
you're trying to get the visa at the same time. And I just want to share a quick story here regarding visas, because I recently had my newest frustration with visas and residence permit. So I got the visa for Switzerland, and the first couple of months you were supposed to apply for the residence permit. You get the residence permit. However, here's another way it can get complicated unnecessarily, and you might get some money out of your pocket. So there's a rule in Switzerland, I don't know, is it in other countries, that if you do not get your residence permit within 3 months and you want to travel maybe for holidays home, then if you want to go back to Switzerland, you have to have like another visa called a return visa that you have to pay for, of course. If you don't have your residence permit, you got to pay more. But then you buy that visa, and usually what they do is they tell you, your residence permit's going to be done very soon, right after you paid it. So you pay for a return visa, and then you get your residence permit. So I think it's a clever way to get a lot of money for the country that I recently had. So I wanted to go back for holidays, and it's just always a hassle with people. You mentioned an interesting point that people don't really talk about so often in academia, which is you've been to many places, but you've also got rejected to a couple of places, right? You wanted to go to DKFZ, you wanted to go to a couple of different PhDs, and it just didn't work out. Maybe the PI found someone else who was a better fit. Maybe the program didn't like your profile for whatever reason. But rejections in academia are so common, even if you're an excellent candidate, even if your GPA is great, even if you have research experience, it still happens a lot and it's hard to deal with it. So can you maybe tell me, how was it for you to get a rejection and then have a plan B and adapt to that? How did you handle that, and in the end found what you wanted to do in that sea of applications?
Of course. Well, I have to say, when I first got rejected, I was heartbroken. I
Mm.
cried and cried and cried and cried. I was like, okay, what is wrong? Like, am I not good enough for you? Like, I really took it to heart, you know? But then after like 200 rejections, I was fine. I have to say, like, no, it's a really, you have to get used to it. It's not always about you. I learned that there are so many factors that can play a role in this hiring process. And for me, the things have always turned out for the best. You know, I was hoping for one path and I would have something in mind, and then I would be really disappointed if it didn't work out. But then, you know, I just kind of shifted my perspective, opened up my horizons a little bit, and there was another opportunity right next to it, you know. And the things were way better than how I would have ever imagined, you know. So, yeah, when I was always a straight A student, and I was always the highest GPA, the best, the best in this, the best in that. And when I got rejected for the first time, it was really like terrible. I got rejected for the first time, and I was like, oh my god, you know, like. But then, when I was applying for my PhD, you know how it is. We usually do not apply to just one position, or at least I don't. I applied to a couple of them. And, you know, I was going through these interviews and I was really getting close to get into DKFZ. And I even got one position, actually. But the PI at that time, she told me that she doesn't know anything about the project, that I will be on my own. And that, you know, she's not sure whether it would be feasible in the end. Like, so I would be on my own. And I wanted to learn. I wanted to learn from someone, so it wasn't really for me. So I ended up rejecting that. But, later on, I was really fixated on working in cancer, and I was applying to strictly cancer working labs, yeah. And I ended up getting rejected a lot, and I realized that it's just the way it is. Not a fit for them, or maybe they sometimes even advertise certain position which has already been internally filled, or for example, you as a foreign student sometimes might not have like privilege like students that are from that country. And there's also, of course, me needing visa. Very few people want to deal with that because it is so complicated. I was just talking about that yesterday with my colleagues, that it's a form of discrimination sometimes, that, you know, they pick up students that do not need visa, even that the student that was like, for my visa, it will be a little bit better, just so they don't go through hassle of getting visa, because it's really, frustrating sometimes. But yeah, what I told myself always was like, okay, fine, this didn't work out. Let's go to the next one. Let's see what there is, And then I realized that, for example, interviews are not just one-way street. They're two-way street. I'm interviewing you as much as you're interviewing me. Like, okay, you're looking for a good fit for your lab, but I'm also looking for a good fit for me.
Mhm.
Like, is this environment that I'm thriving? Do I like you as a mentor? Or do I think you would be like what I need? Because not all students are the same. Some need a little bit more control. Some need, to feel free. Some, it's different. So it has to be really a match. And once I realized that, I felt really relieved. I stopped taking it personally. It's not. It's just the way things work. And even now, I guess, like, if you apply for anything, you will be rejected. It's okay. Just, I think it's important not to give up. But of course, I made mistakes while I was applying for my PhD. And for example, I mean, now after years, I would do certain things differently. And then I was also like, I'm always thinking about when I see some of your posts on LinkedIn, I can't wait. Why didn't I do this? Like, it's so like black and white to me when I read it somewhere, but I never thought of it. And like, I wish I read this like 5 years ago.
No, I'm
You know?
happy. I'm happy you're seeing my posts that way. I think one thing that's super important and that I've seen countless times that you just mentioned is just taking rejection personally. And I think for people who are going into academia, it's a little harder than for other people. And the reason I think that it's because the profile of people who go to do a master's and a PhD and a postdoc, they are the students who always got told they are the best, right? You're the best. You're so smart. How can you think so fast? How do you even get such good grades? You don't even study. When do you even study? And then all of a sudden you shift from that to, sorry, your application was great, but we decided to go through with another candidate. But do not despair. Your candidacy was very strong, and try somewhere else. And you're just listening to that, and your heart is breaking in half. So I had a couple of acquaintances, amazing students, super high GPAs, if that's one indicator, won competitions in biology. Some of them won Olympiads, and one of them got rejected from a master's program. And I couldn't understand how personally he took it. Like, we had this conversation about him not feeling good enough. Am I not good enough for this program? I'm just a nobody. Like, all this negative self-hate talk. When in reality, if you just back off a little bit and you try to distance yourself a little bit emotionally, and you take a look at the numbers, how many people did they accept to this program? 12. How many applications did they get? 800. So out of those 800, because it's a super selective program, probably half of them are all amazing students, and it's a global program, so everybody applies. Everybody from around the world can apply. So you get the best of the best applications. So everybody's in the top. Everybody has good GPA. Everybody has good recommendations. Everybody has good cover letters, CVs, everything. So then the power to discriminate between students gets down. And I was even told by one committee member who was deciding for these selective programs, oh, in the end, you just you go with your gut feeling, one of our colleagues, he likes musicians. So if he sees that if you're a musician, he might give you an advantage. So when you think about it, really, if you were in those shoes of someone who's selecting, and you had all these top students, like 200 of them, how would you decide? Probably it wouldn't be personal. It wouldn't be, this person is not worthy or not good enough. It would be just, I don't know what to do. This one sounds more interesting a little bit to me, right? And
Yeah, or
that's
they
how
did
people in the
2
end.
Western plus more than you, and you're like, oh yeah, that
I
they
don't
have
know.
more experience.
Yeah, it's just the element of randomness. Like, okay, maybe someone who has more experience in this particular technique would fit better in my lab because they're going to be doing it anyway. So I have no other discriminatory factors to go over it. So I think it's to conclude this rant, it's just very important to back off a little bit and understand that it's just a numbers game. And even if you're at your very best and your application's great, it can get rejected because of some randomness, because somebody likes musicians, and it's just because there's so many candidates. Okay, so you do your master's. You did some cancer research. You said you love doing cell culture. I don't know what's wrong with you to enjoy liking cell culture. Maybe I'm the opposite dirty fly person who never wears a lab coat and never wears gloves. Tell me a little bit about your interest in cancer. Like, how did you get into that field? Why did you get into that field? What aspect of it was interesting for research? And then maybe guide me through your PhD. What were you working?
Yeah, I think my interest started in high school. I had a really, really great biology teacher, and I don't know, it was one of those aha moments. You study for all the subjects when you have an exam, but I never studied biology because I could just see it play so well in my head. Like I could just imagine the process, and I saw that I have really I have something for that. I have a love for this. And then there was this teacher and was really talking about it super passionately, and just cancer itself, I guess the challenge of it, the resistance of it, like you think of everything that could help it, it's kind of turned on, and the way it surpasses the natural barriers to stop it, it was like wow to me. And the fact that most of the cancers have treatments, but they're not as effective, or they're really harsh, it also sparks an interest there. But then during the university as well, I started learning a lot about cancer. And really, cancer was, I mean, it still is, but at that time cancer was such a hot topic, and I couldn't help myself. I was also hooked on this. When I got to this institute in Barcelona, most of the people were working on cancer. I was not working on cancer, as I told you, but I was working with cell lines and cancer cell lines. And I love cell culture. I don't know why you don't like it, but I love it. I don't know. I just like, taking care of these cells. They all have their own personality, I would say. No, really, they do. Some of them like it a little bit. I don't know, the density of the seating should they like to be together. Some of them like to be a little bit, further apart. They need space. They grow slower. They grow faster. Like, I love it. I really do love it. And actually, most of my PhD, I was working with a lot of different cell lines and also primary cell lines. So I really enjoyed it. I don't know. I loved it.
Primary cell line being just ones that are taken directly from the patient. Okay.
Yes. And then,
okay.
We can also get a mix of all sorts of different cell lines, like for bone marrow, for example, and if you decide that you want to culture them and take only certain ones, you have to go through certain process depending on what you want. And of course, all patients are not the same. So from one patient, it might be really easy to culture them. From other patient, it may be a little bit more effort. You need to adjust the media, and certain things take out others. It's like a fun game to me. So I really, really loved it. So during my internship in Barcelona, a lot of people were interested in cancer, and we had these seminars in the institute, all together. And I was really always saying, oh my God, I just wish I worked in cancer, because it seemed so interesting. I think the thing that has the most, well, there were two actually things that were the most appealing to me. So it's very translational. So first of all, I feel like you could directly see an impact of your work on people's lives, and I think also these encounters with cancer patients, especially for example with multiple myeloma that I worked on, you're really oh my God, this is why I want to do something. This is why I cannot just stand and watch. I want to do something for particularly that person that you're seeing right now, to you see them interacting with their family. Multiple myeloma is treatable, but it's incurable. This person will die. Or, for example, we would get some biopsies from multiple myeloma patients, and one day like registering the number, and then you want to do a follow-up, for example, for whatever reason, and you're like, no, they passed away. And your heart skips a beat. I've never known these people. Like, I didn't even speak the same language, or I might have never seen them ever. But you still feel this drive, like, I want to do something. I want to help. And with cancer, I feel like it was, you could kind of see your impact. Like, you'd say, okay, I saw that this protein was important, so maybe we could target it with something. We're still in this initial phases of the research, and of course it'll be years and years until we would see something, but you still feel like you're contributing. I mean, it's not, of course, just you, it's like a pool of researchers. And then also because it's just so interesting, like the biology of cancer is so interesting, like the pathways, the differences, how it adapts. It was always so challenging, and then therefore interesting for me. So yeah, that's why I wanted to do something related to cancer. And I ended up being in blood cancer research group, and I ended up working on multiple myeloma the most. And as I said, multiple myeloma is treatable but incurable. So it doesn't, like, the treatments that are existing now are basically just prolonging the life. And it relapses. It seems like the cancer is gone, but then it relapses. It means it comes again. And it becomes usually resistant to the therapies that you have already given it. So you have to kind of switch up, and you don't use one chemical, for example, you use multiple agents at the same time, but still the outcome is unfortunately death,
So,
And then
let me just cut in a little bit here. So when we say cancer, when you first hear about cancer, you think of it as one disease. But as you delve into it, you see that it's actually maybe hundreds of diseases that are very, very different from each other. Kind of like when you say sports, you have tennis, but you also have, UFC and MMA, right? Very different sports, but we call them sports. So what is multiple myeloma, and how different is it to other cancers? Maybe just guide me a little bit through that.
Yeah, well, I also have to say that, just to add to what you just said, you have tennis, but you also have table tennis. And then within that tennis, you have this weird tennis where they're like trying to hit the ball with their feet across the net. I mean, there's so many versions of the tennis, and it's the same thing in cancer. So like multiple myeloma, there could be like different manifestations, and different things happen. But basically, multiple myeloma is characterized by uncontrollable proliferation of abnormal plasma cells in bone marrow. So what does that mean, Rebecca? So you have plasma cells that are cells in your body that are secreting antibodies. Right? And I think because of the COVID, a lot of people already they know a little bit of, antibodies, vaccines, and so on. But yeah, what I'd like to say is that antibodies are like little flags that attach to a certain, let's say, cell that needs to be destroyed. And then all of the other immune system goes and destroys it because it's already been flagged with this antibody, let's say. And here we have abnormal production and proliferation of these antibodies. So first of all, they're useless. They're useless and they're there. So they're clogging up. First of all, the concentration is really high, and then they can even deposits in kidneys, because kidneys are filtering the blood. So then multiple myeloma patients have a lot of kidney problems. They have anemia because bone marrow is a site where you have blood cells production, right? So these aberrant, like crazy plasma cells that are useless, are taking up all the space for the production of other blood cells that you need. And therefore you have a lack of these cells that you need, that should be healthy. You have a lot of these unnecessary cells. So you can be anemic. You are more prone to infections, for example. And then can you imagine the proliferation of these plasma cells within the bone marrow? The bone can be broken with it, because there are so many cells, and multiple myeloma patients really have a lot of pain, like they're enduring a lot of pain. And of course, multiple myeloma can occur in multiple places of the body. It can be, a spine, it can be ribs, it can be skull, it can be hips, like it can be anywhere and multiple places at the same time. So it's really
Is that why it's
painful.
called multiple myeloma?
Exactly.
Okay. And okay, so how gradual of a process is it, and how early can you actually diagnose? Is it just that the patient suddenly starts producing all of these antibodies, or are there multiple kind of triggers that happen over the years, and then slowly you discover, you're elevating your antibodies for no reason, and that could be a sign? Maybe just tell me about the...
Yeah. Oh, well, it can be gradual, but it can be all the time. Or maybe you diagnose it like at this moment when it already started. We haven't had this previous diagnosis, so it's really difficult to say. It doesn't have to be that it's gradual, but you also never know if it's gradual or not. Yeah, because there are stages with the age. Even multiple myeloma is usually with the patients that are, let's say, not older, but like above 65. Like that's the median age. But during AG, basically, there is a couple of these aberrant plasma cells, and you can have a little bit related antibody reduction, but there are certain thresholds. Yeah, so there are some like pre-stages, let's say, and some of the hematologists or hemato-oncologists are trying to also find a way to prevent this, to even give therapies to people that are not yet qualifying for multiple myeloma, but they are getting there. The thing is, only so I might be really wrong now, I think only 1/3 or less is gonna pass from this initial almost multiple myeloma to multiple myeloma. So it's almost never. Yeah. So it's like, is it
then you're
worth it?
risking, I guess, side effects for those people who might
Exactly.
never get there anyway. Okay.
Yeah. So it's like, it's tricky. So yeah, indeed, multiple myeloma has these pre-stages, but usually the diagnosis is when it already happens. And to make things worse, there is a metastatic form of multiple myeloma, as this was not bad enough. It's called extramedullary multiple myeloma, where you have these aberrant plasma cells go out of bone marrow, and then they start making tumors on all sorts of different organs around the body. And then you have a very, very big problem, because at that point they're really not reacting to the therapy that you would give to multiple myeloma patient. Okay, this inflamed tumor has changed its characteristics, and it will not react. So the patient is usually dead within 6 months, and it's not so common. But it happens. And I think it wasn't researched a lot, but for example, my group has really put a lot of effort into researching this. So even from these initial stages, single cell sequencing, we have a paper coming out soon. It might be even now if this podcast is out. But yeah, even the smallest findings are really nice to see. But yeah, multiple myeloma is very prone.
So from the moment of diagnosis, you have about usually around 6 months before death. That's kind of the outcome. Did I understand that correctly?
From extramedullary multiple myeloma,
okay.
Usually. Extramedullary multiple myeloma. For other multiple myeloma lesions, it's different. It depends.
Okay.
It depends how the patient is reacting. As I told you, the number of relapses and how long does the remission last. Yeah.
So it can be, let's say, but it's not like you're going to get diagnosed multiple myeloma and you have another 10 years of life. Or are there people who have some kind of mild version? Okay, so a couple of years is maybe the best case scenario. And so you mentioned this phrase once before we started and once now, that it's treatable but not curable. So you can, what are our best strategies to attack multiple myeloma? What are the best guesses how to slow it down? Or
Yeah, it is treatable, but it's incurable. So whenever you do, it will most likely come back for now, and we're hoping to reverse. So I also said that we are using combination like of different agents.
Mhm.
So you're usually like adding a couple of things, and there are already established guidelines on how would you combine these. But basically, you're also calming the immune system. You're like trying a lot of things. But what is very popular right now is something called immunotherapy. So what does it mean? That you're trying to use your own body to kind of train it to fight against this cancer. Yeah, to try to destroy these cancer cells. And one of the ways that you can do is by using monoclonal antibodies. So you like exogenous multiple monoclonal antibodies, sorry. So you are injecting these monoclonal antibodies that will selectively bind to your cancer, which will then flag the cancer cells and will kind of give a signal to your immune system, hey, you should destroy this cell,
Mhm.
you know? And this is one of the approaches. And the other could be, for example, I don't know how familiar you are with the T cells. So there are CAR T cells that are basically the cells that are killer cells. They can kill another cells and destroy it. And what you're doing here is you take take the cells, T cells, and you try to make them more specific towards this cancer cell so that they can detect them better. But at the same time, you try to make them stronger so that when they do start feeling that their killing is like more effective, let's say. So this is another strategy. However, this is really new and expensive, but it's going well. Like the results are promising. They also have engineered NK cells, so T cells. There are monoclonal antibodies against a lot of different like markers. For example, CD38 right now is very popular enough. There are antibodies against CD38 called daratumumab and isatuximab. There are some other ones like against LAMF7 on cancer or BCMA, or there's like a variety, and people are trying different combinations of these immunotherapies with already existing treatments, because there were like treatments like doesn't just kill all the dividing cells, and you have like cancer cells divide more, yeah, so you would kill indeed a lot of cancer cells, but then you have a lot of cells that are dividing that are
Then you
healthy.
are
So you
selecting. It's kind of a red queen hypothesis, where you're catching up and she's just leaving more and more and speeding up the division even more.
well, actually, you're killing these dividing cells, but it's not selective. You're not just killing cancer cells; you're killing yourself too. I mean, your own body, because cells do replicate. Yeah, so there's that. So I would say it's very complicated, but I think with the new, like, immunotherapy seems really promising for me. But it costs a lot of money. And for example, CAR T cell therapy is very expensive. I think it entered clinic for multiple myeloma, but it's really expensive, and I think not a lot of people like us can afford it. But I think with time, as everything, it would get cheaper, and we might come across even something better, you know.
So one problem that I've often heard about in treatment of different types of cancers was you find a marker to try to destroy these cells that is common to cancer cells, but then either it's not selective enough, meaning, as you said, it starts killing your own body as well, and then you have a lot of consequences because of that, or these cells that are in the cancer are super heterogeneous as well. So even if you find something specific, you find it specific to one group of cancer cells, but then you just kill those and the other ones survive and then they multiply. So is this also the case with, like, when you say you try to destroy these cancer cells here, are they also heterogeneous and you can destroy one, and this is the reason why people relapse so often?
Yeah, that is one of the reasons. At some point, like, so it could be that, for example, even if the population of cancer cells is homogeneous, and we say, for example, that they do express all of them, CD38, for example, and that you would target them all, but maybe your nose is not adapted enough to this one, and you might not kill all of them. But that's unlikely case where they're all homogeneous. Mostly they're heterogeneous, and for example, most of them can express CD38, and then you kill like most of these that express CD13, but you're still left with a little bits of others that you cannot kill. So we're trying to find out, that's why I think combinatorial therapy will be the future, because you're attacking from different sides. Of course, I think it's going to be very harsh for patients as well. And there has to be this left balance where you're not killing your patient while trying to help the patient, Also, for example, in the case of multiple myeloma, so there's the CD38 that is expressed in multiple myeloma cells when they're in bone marrow. But when you look at the cells in extramedullary multiple myeloma, you see that they're the expression of CD38 is more or not exist. So it seems like also there are papers that extramedullary multiple myeloma incidence has increased over last years. So you might think that by trying to help patients with these monoclonal antibodies against CD38 while they have multiple myeloma, you kill all the cells that have CD38, but then you're left with some that don't have so much CD38. And maybe these cells end up leaving bone marrow and making these tumors that you can know bigger forward. It is not completely known. It is not sure what their destined face. But you see how complicated this is? It's really like a puzzle. And there's a lot of research needed to see what could happen. Or, for example, maybe now, if they were to see that in extramedullary multiple myeloma you have another X marker that is on these cells, then maybe we could try to have a combination to target, while there's multiple myeloma still not extramedullary, to target both this CD38 but this new one also, that is expressed in extramedullary. So you try to kill them both. Maybe. That's just me on top of my head.
To me, it feels, every time I talk about cancer with someone, which is not a lot, but sometimes I do, it always seems like a fight with viruses. You come up with something and then cancer comes up with something else, and it's always this race, and this example you gave, it's quite terrifying that you find it's always about this selection. You select for 99% of the bad cells, the bad guys, but then there's that one that's super dangerous and he's hiding, and now he multiplies. So it feels like a never-ending race, and I really hope some fundamental progress in biology contributes to solving this in multiple myeloma and other types of cancers as well. Okay, very cool and very interesting topic from a biological standpoint of view. Tell me a little bit more about your experience as a PhD student in Czech Republic. So you get the visa, right? The visa is done. We can skip the visa. That's the part that's we know it's annoying. And then you start your PhD in Czech Republic. Presumably you've never been to Czech Republic before.
I've been to Prague, but Manchester, which is like completely different.
A different world. Okay. So tell me, how does that process go for you? How do you adapt? What are some challenges you encounter? What are some positive things you encounter? Guide me through your PhD. Put me back in Ostrava.
Oh yeah, well, I remember when I first arrived, I was like full of energy. I will crash this PhD. I finally got a PhD after 200 applications and interviews, and 1 year of searching for perfect PhD. I was like, buzzing with, I want to do this. I was so ready. But then I come to Ostrava, and first of all, it's like the city was not what I expected at all. It's an industrial city. It is the third biggest city in Czech Republic. But, I always ask, what is this? Where did I come? And then, you have to think about it like, oh my God, I'm going to live here for the next at least 4 years. So what am I going to do here? But then luckily my lab, it was quite international. So there were a lot of international people, which I not expected in one Ostrava, to be honest. But because we were all international, most of us actually, we were really close to one another because none of us had a family there. So if you were to do something, you would mostly go with them on the weekends, and, so you would not visit your family, but you would go with them for a swimming pool or something like that. So basically, I had the most amazing colleagues who actually taught me most of the techniques and have been like my family there. Let's say I was really, really close to them. So I was really lucky in that way that I had the most amazing colleagues. And then the cancer research in itself, I had an initial topic that was really interesting. And I pursued this topic for, let's say, a good year. And then we saw that there would be nothing coming out of it, so we had to stop. And this was really disappointing for me because I really loved the topic that I was working on, but we couldn't get anywhere
Could you
with
just
it.
tell me
And
why did it have to stop? Was it because it just wasn't feasible scientifically, or you got a bunch of negative results, or lack of funding for that particular idea? What was the reason to stop?
well, first of all, the main thought was I have to finish ideally in 5 years. And if we continue doing this for the next year as well, it means we might not get anywhere. There are there were no promising leads. We were still trying to find the best model to study this. And after like a year of failures, we had to like choose yes or no. Do you want to pursue with this, or do you want to try something different? And at that point, there were other more convincing leads that I could follow, so we just decided to go with those. So I had a switching project, right? Like, let's say, like at the beginning. And then it meant that like I had 3 or 4 years of my PhD left. And then there was like the panic moment there, because, I'm nowhere. Like I'm starting something new and I don't even know if I will be able to get something out of this. There's always this panic. Like you're obviously trying to follow a lead and you know that it could get you anywhere, but that's the research. Yeah, that's the research. You don't know for sure that you will get something. And then you know how it is. You need to publish. How in Czech Republic you need to publish 2 papers where you're just the co-author, and you should have 1 paper where you're the first author. So it should be like a PhD. And at that point, I was already panicking. Well, if I have nothing, and it was kind of challenging there just to like align my thoughts with okay, this has not worked out. Let's go with something else. But at the same time, I was working on a couple of other projects where I learned like single cell sequencing technique. It was at that point it was very hot topic, but even now I see that most of the papers are using single cell sequencing technology.
That bumps up the journal you can submit
Yeah,
to
yeah.
by a lot.
Yeah, immediately single cell sequencing.
Oh, we did a single cell.
Exactly. But it's really expensive. I mean, it's such a good technology, I have to say, but you have to be really precise. You have to have a good plan. You have to have a lot of money, I have to say, to do this. And then you have to know what you're looking for. Because if you're not sure what you're looking for, or if you're just exploring, it could be that you don't find anything.
Let me just take 1 second for you to tell me, like, why is single cell sequencing such a good technique, and why do so many people love using it? Besides, we used single cell sequencing, right? What does this technique tell you? What kind of question can it answer so it's so popular?
So looking at what we previously talked about, looking at the cancer, we said it was heterogeneous. So when you do bulk RNA sequencing, when you take all these cells, you will just get an average. It's like with the juice, for example. If you put 7 bananas, and if you put 1 apple and maybe 2 blueberries, if you mix it, if you blend it all together, you will feel banana the most. Maybe you will not even know that there were 2 blueberries. Yeah. Think of that in terms of cancer. So if you have like a tumor that is heterogeneous and it has 7 bananas, 1 strawberry and 2 blueberries, and your therapy is targeting these bananas, and most of the cancer will be gone, but you will have this strawberry and these 2 blueberries that you never knew about. And these blueberries may end up being the most resistant clones that proliferate the fastest and can make like such a boom in your body, metastasize, be so aggressive, and be really difficult to treat. And maybe you don't have an option. You don't know what they are. You don't know how to treat them. So you see, it is very important to know the entire profile, not just to have a smoothie, but to know all the list of ingredients that you have.
I love that analogy, especially because Smoothies are one way for me to sneakily ingest spinach or something like that, because you completely don't know you're having spinach in there. Because if you just mix spinach and banana, you feel the banana, you don't feel the spinach. But you got in the spinach. You might not even know. If you didn't know didn't see the color, then you got some spinach in there. I love that analogy. That's a very nice one.
Yeah, so that's just what we do
Mhm.
with single cell, basically. You are able to detect even these two blueberries. So you basically have single cell sequencing. All the cells, you will know the profile of RNA profile of all the cells that you have analyzed. So then you can cluster them together. You can see most of them are this, most of them have this marker. But look at these, they might be like different, or are they resistant? You can do a lot of things. And for example, for us, we explored extramedullary multiple myeloma with this PE. So basically, we don't know what these tumors are. We don't know what these cells that exited the bone marrow and make these tumors are. So we wanted to see the profile. I was like, okay, what are those? So that's why it was very helpful, and that's why single cell sequencing is very helpful. But as I said, you really have to know what you're looking for. I think it's like exploratory, great, but then you have to use your data like wisely. And sometimes it's not just it's just not worth it. Like in a couple of journals or papers, actually, I've seen use of single cell sequencing. Like, why? You could have done bulk RNA sequencing, which is like 10 times cheaper, but single cell sequencing. So
Yeah. So going back to your first year of PhD, you go to this project topic that you like. It goes nowhere. It fails. By the way, I've heard this story maybe 10 times in the last month about different PhD students in Switzerland that just finished their PhDs, and I asked them, hey, how was it for you? And I think everybody had this story. Like, first year I was enthusiastic. I wanted to do this and this and this. I came up with my own ideas. And then after 1 year exactly, I had a panic mode because it was going nowhere and we had to decide. So it's such a common thing. And it's very funny because right now I'm at the half of my first year and I'm feeling that moment's coming. So it's quite reassuring to hear this. So you switch topics, you decide, okay, do you then decide, let's do something safer that's kind of guaranteed to produce some kind of outcome?
Exactly, yeah. But even that was not going places. And oh my god, that was really, really bad. Like at some point, we realized that we had like some technical issues. It was a mess, and that also was not going anywhere. And then there was a real panic. So this was nothing. The first panic moment was nothing compared to this one, because the first panic moment I thought, still is fine. I have 4 years, like it's fine. I can do this, like. But now it was like, oh my god, I really don't know what to do. And then I kind of joined like multiple projects, and I was working on a lot of them parallelly. One was the single cell sequencing, which I really loved. Extramedullary multiple myeloma is, thanks God, not so common. So you need a lot of time to collect 3 patients. You might need like 2 years for this. So you need time for this. And then I was working on another project which was more methodological, and that was also very funny because there was a methodology that we wanted to use, and it was almost like a done deal. We just needed to do some cloning, and the methodology was shown to be working in the journal, like in the paper, sorry, and we just applied it, and we saw that it's not working. So we were like, okay, this is not working. Let's reach out to authors, and I don't know, we couldn't reach them, and then we were trying to modify it, and like 3 months turned into 6 months, into 9 months, into 12 months, and it ended up being a very methodological project. Like I was just trying to adjust the methodology so it works, and in the end, we decided like, okay, if we make this work, we will just publish it as it is, like adjustments to this methodology. But then later on, at that moment, I was really like, oh my god, I really want to publish a paper and told people that this is not working. Like, oh my god, can you imagine how many people, because it was one of the few technologies that could work for this specific purpose. And I'm sure that many people try it and it didn't work. But you're like losing your time on this. And then I saw now that there are adjustments to this methodology, like improvements, So I mean, that's great, but for me, it didn't work. And I spent like a lot of time trying to make it work. And something that should have been like 3 months of work turned out to be 3 years of work, and it went nowhere in the end. And then I was also working on some more like projects related to the therapy. And in the end, my first author paper turned out to be a basic research paper, nothing to do with cancer, because we ended up finding something for you better.
What did you find? What did you find?
Yeah, it was about translational efficiency of long and short MRs.
Okay.
So, yeah, you have it's an interesting story because it's a little bit controversial, I have to say, because like most of the housekeeping genes are like the most expressed in the cell, and they're usually very short. They have short mRNAs, and for some reason, so they're really short, and for some reason they're like expressed a lot. But when you think about a translational cycle, you think, okay, there's one mRNA and one ribosome will be on it. It will translate it, it will fall off, and then you need another cycle, for them to bind and translate again. Well, if you have longer mRNAs, you can have multiple ribosomes translating at the same time, and this could mean that they have a higher efficiency. And we were specifically looking at the ER bound. So you have a representative on the ER, and then we were looking at the efficiency of these long and short mRNAs. Well, in the end, I would suggest that you read a paper and be critical of it, see what's happening, because in the end, it gets really kind of complicated because you have these loop factors. I'm not sure if that's the correct term, but there is like a theory that these short mRNAs are kind of looped so that the ribosome goes round and around, that there's no need for initiation factors to come again, and so on. So it's very like basic science, with something I have to say I'm not interested in. I mean, it turned out to be my first author paper because that's how it was. But yeah, I would rather be working on answer. But all that to say how unpredictable your PhD can be and what can happen in all this. So yeah, do not give up. Even if you fail, you will say something will come up.
Yeah, I think that path is just unpredictable. And I think I too, and I think most people who are starting a PhD are super enthusiastic, and the reason for enthusiasm comes from not really understanding the timeline for research. How long does it take actually to produce a result that is real, that is not some kind of artifact, that is reproducible? You can do it 3 times, or at least, and it's the data is nice and obvious. It's not like your error bars are overlapping, and it's like you're trying to do some messy statistics to try to figure out is it real or not. It really takes time, and in my first, I've been doing a PhD already 5-6 months. I had at least 3 or 4 results that were amazingly exciting. How these antimicrobial peptides can go and do some damage in the nervous system or the blood-brain barrier. And then I see, I did not actually include that one control, but it's going to be fine. It's going to be fine. And then you like, let me now repeat this experiment with all of the controls. And then you include the controls, like, the reason for this result was because I'm stupid. I guess that's where your mind tends to go to, like, why didn't I just do a proper experiment? And sometimes you do a proper experiment and there's some variable creeping out from nowhere and you see the result. It's super exciting. You repeat, it doesn't work. Why doesn't it work? You figure out 2 months later that it's not working because some stain that you put in is degrading super fast, and that's producing 3 different chemicals which go to the brain and do something. So it's just this timeline to produce a proper result that's reproducible and real. And then because you have to build now on top of that result, that just takes a long time and a lot of bloody work. So yeah, I'm starting to learn that myself, working on something that is producing artifacts all the time. Maybe it's me, I don't know, but I guess
But
other
that's
people have
normal.
similar results, right?
But that's completely normal. And the fact that you said, okay, it makes me feel stupid. I felt stupid all the time. I feel stupid even now as a postdoc. Because you're like, oh my God, I really don't know. It's challenging. Learning is challenging. You're not in this routine where you're doing all the same things over and over again. You have to read, you have to learn. I think learning is uncomfortable. And you are always faced with a problem. You find the answer to your question, and then from there, you have another question, and then another question, and another question. And you have to be, anticipating like which direction it will lead you to. I think it's perfectly normal to feel stupid, as you say, inadequate, or to feel this imposter syndrome. Of course, I mean, I like to remind myself, first of all, this is research, right? I mean, if it was known and if we knew all the answers, I would not be doing this. And it is difficult because you're trying to get answers to something that no one has ever done before. And it is normal that you feel stupid and inadequate and that you produce bad results. But all the big discoveries were kind of made by accident. I don't know if you know about this microRNA discovery by Craig and Mello,
Tell
where
me.
I don't know, they I don't know the full story, but they discovered these microRNAs because they left their worms. They forgot about them. They just
Mm.
left them. And they came I don't know, weeks after. Don't get to the timeline correctly. I'm not sure that I know the story, but the point is they forgot about their experiment and they looked at it and so even the mistakes can be really beneficial. It's fine. It's fine. It's okay to feel inadequate. It's okay to feel like you're not doing well enough. But you should really talk to yourself, have a conversation with yourself. Hey, I'm doing something that no one has ever done before. I should give myself some credit. I have learned 7 new techniques in the last 7 days, and I have learned 3 new statistical techniques because of this. And we don't think about that. You don't think about how you're overcoming these challenges, how much your brain has to work. I think personally that anyone with a little bit of intelligence could finish PhD, but it's not the intelligence, I think, that is, or how smart you are, or how successful you are, that is determining who will finish the PhD. I think it's how persistent you are, how mentally okay you are, how you talk to yourself, how you understand this, world that you're in. Of course, it's challenging. You're constantly learning something else every day. You have to read, you have to keep up, it's normal that you learn 3 new programs and 7 new techniques, and then you buy some chemical it's super toxic and cancerogenic and everything, and you have to casually not wait 0.2. Of course, of course, it's challenging. It's fine. You're gonna be fine. It happens.
I
But
like
what you
one.
learn from this experience is that you lose your control next time, and that's fine. Now you'll
That is
never forget
definitely
your
true. I will
controls.
always use controls. In my lab, we
Exactly.
say controls are for cowards. Uh, so I like this one quote by this professor. He says, it's called research because you search and then you search again. You have to search again. You have to keep searching. But yeah, kids, use the controls, because even with the controls, there's always something creeping up and causing your effect that you don't know about. So prepare for that. Okay. So, okay, in the end, you get the paper out, and it's something you did not expect, the topic you weren't really even imagining you would be working on in the beginning. So how was all of that for you mentally? You mentioned it's important to be mentally okay. And I imagine that when you're working on something for a year, you have a panic attack because now you got to switch. And then you switch, and that is also not going nowhere for a long time. I don't think I would be okay, and I don't think many people would be. So tell me, how was that for you mentally? How did you deal with it? How did you put yourself back on your feet and just handle all of that?
Yeah. Well, I have to say I wasn't okay. Like at first time I was fine because I was like, oh yeah, I have 4 more years, it doesn't matter. I don't have to even longer, so what? Like fine. I can finish this PhD. But then the second time it was more of a real panic attack. Um and I really started struggling. So first of all, I didn't know what to do. Everything was new again. I could see also myself comparing to people in the lab that were already like, there were people who just started and they had incredible results. And there was me, I was like in my third year and nothing, you know? So it was really discouraging. And I think it was my third year that I really started feeling the pressure. I really started, you know, I could see that all the things that I like to do besides science, I really kind of stopped because I would just panic about my PhD.
Mm.
Like, I could not, let's say, enjoy myself because I was panicking about my PhD. And it really got to some point where I was really questioning my mental health. And of course, every PhD student sometimes thinks, oh, well, if I quit, like, I should quit. Like,
Just go
it
to the
happens. It
industry.
just happens. Yeah, definitely. And then I also saw that my physical health was really getting bad. I was experiencing a lot of brain fog, like most of the girls nowadays, unfortunately, a lot of hormonal issues, a lot of, one moment you're just like losing yourself. I did not know who that Hana was anymore. And I just wanted to do something about it because it came to a point where I would like see a doctor and they would give me something and it just made things even worse. And I just said, hey, you're doing a PhD. I think you can help yourself, like read a little bit, see what is the problem, and, try to do something about it. And in that moment, I think I really like rock bottom. And like, first of all, I couldn't think. And then I was not feeling well. I was feeling a lot of anxiety, a lot of stress, even for nothing, everything could be fine, but I'm still anxious, I'm still stressed out. And then, my physical health started deteriorating and it was really not nice. And then I started like helping myself. I hired a coach, first of all.
Okay.
Yes. And she's like, it was in terms of like, let's exercise. Yeah, like physical exercise.
Okay.
I was gaining weight because of my hormonal issues, having a lot of different like brain fog, not knowing who I am anymore. And I started exercising and I really saw a positive change in myself. Then I started learning about food, about micronutrients, about timing of the food intake, about the intermittent fasting, about, like energy homeostasis. And I became really interested in this field and I saw that there is entire, like, I would say a religion there, literally people who are like fitness fanatics. And I started listening to Andrew Huberman podcast, all of the other fitness podcasts. And I became much better. I solved all my hormonal issues. I stopped feeling anxiety and stress. Of course, I do still feel it sometimes. It's super normal, but like in that extent, it stopped. And yeah, I lost a lot of weight, which was very nice. And I started like cultivating this love towards science in weight loss, obesity, nutrition, and that became my, let's say, second interest. I also started doing Zumba, which was
Okay.
very unexpected. Yeah, and I enjoy it very much. I still do it, and of course lift weights and so on. But yeah, so this explains why I kind of switched from multiple myeloma to a postdoc in circadian rhythm. So I was really interested in, as I said, macronutrients, like the nutrition. But then there was this new discovery, and it was a very hot topic in the fitness industry, and that is the circadian rhythm. And now I saw that they have here in KU Leuven, they had an open position as work, but circadian very well. But yeah, I'm gonna apply for sure. So it was a very strange choice, even for my current PI. And she's like, okay, cancer to circadian rhythm, you'll have to learn everything all over again. I'm like, yeah. And when I explained the background, she got it and I got the position.
Just do the single cell sequencing, it's going to be fine. So when did this transition happen? So you have these two panics about your PhD, you're constantly stressed, and then at which point do you, let's say, flip to this positive side? Was this a third, fourth year of PhD?
This was the third year.
And how long did it take then from that mental shift of understanding, okay, I really have to do something about this, to actually, I know, because I know this takes a lot of mini steps, right? You need to change a little bit of diet, a little bit of sleep, a little bit of exercise. All of that takes a long time to switch all of those habits. So how was that time for you?
So I think that it got like from bad to worse during my second year, and it took like 6 months to get to a total disaster. And then I think in my third year, I kind of woke up. But this changes took like a year and a half to get to some point. It's not overnight, as you said. You need to really invest time in this, and you have to be consistent, I would say.
Okay. So you get interested in this world of health from the standpoint of fitness, of your lifestyle, let's say, and you apply to Belgium. First of all, how is it different applying for a postdoc versus applying for a PhD? Is there a difference there? And then how is it different being a postdoc versus being a PhD student?
Well, I can only speak from my experience. I applied to one postdoc position and I got it.
100% rate.
Yeah, but like compared to my PhD, like I had to apply to 200, different places to get somewhere. Here I just applied to this one. And to be honest, it was the most straightforward process. They just require a CV and a letter of motivation. And that was it. I got it. I had an interview. And I think that I could have called Reds next day. So it was really nice. Like,
awesome.
no stress.
Yeah, I guess if somebody recognizes how motivated you are to get to the position, it makes things a little bit easier. Okay, so then how is it? We'll go back to what are you doing in your postdoc and how are you doing? But just tell me, from the point of doing science, you're now in a different place in the hierarchy of the lab, because when you're starting as a PhD student, you're kind of just, you're all over the place. You don't know what you're doing. Now you kind of know a little bit of what you're doing and how to be independent and all of that. So maybe tell me, how is the experience of being a postdoc versus a PhD student?
Yeah, well, I can only, of course, speak from my experience, and it is very common to go from PhD to a postdoc in a different subject, which I did not do. So I had to learn everything, basically. It's a new topic. I mean, I had knowledge. Of course, I did have knowledge, but I didn't have like molecular knowledge, or I did not know certain pathways, because at that moment when I was going through, because I didn't care about molecular pathways, I just needed to know what I need to do to get better. So I had to relearn a lot of things, and then the techniques that are used in the current laboratory are mostly the same as in my PhD, but there were some that were new. So I had to learn, and there were students, PhD students, that started at the same time as we in this lab, and we had to go through the training together. So it was me and PhD students at the same trainings, and I'm sometimes blown away by how good these PhD students are. Sometimes I'm like, oh my god, do I deserve to be a postdoc? Because they're so good. But you see, it doesn't stop. It doesn't stop now you're a postdoc and you're like, oh yeah, I'm the best. No, I always feel like, okay, I feel this imposter syndrome. But I think it's normal. I learned to live with it, and I just, get over it. But in general, the postdoc and PhD differences are that postdocs are like generating ideas, managing projects. So in PhD, mostly, I'm saying mostly, and get your ideas from your PI, kind of. You also discuss if you're still learning things, they give you more direction and so on. While in postdoc, I would say that you generate more ideas, and if you have a certain direction, you kind of just have to persuade your PI that why would it be feasible to go into that direction, and you'll just follow it. And I don't know, in my case, I kind of, I work with PhDs and, assist in multiple different projects. I'm not focused on my projects, and you get to chair conferences, present in seminars, and so on. I mean, there is a hierarchy, you can definitely see it, but as I said, because I started anew, I'm still like, I still feel like a PhD sometimes, but I'm not, yeah. So,
Do
yeah,
you feel that
that's
when you discuss, let's say, with your PI, do you feel that your ideas are more valued than if you were a PhD student? Like, that's a good idea. Maybe you should pursue that. Versus a PhD student, do you feel just this discussion being more on a level playing field with the PI? Because when you're a PhD student, you kind of, even if you suggest something, it's like, I tend to notice that it's much more easily shut down. Maybe as a postdoc, you get a little bit more freedom and liberty to.
in my lab, the case is you have an idea, and the PI says, okay, can you tell me why? And then if you're able to give the background on why, and why do you think this is, and if you answer to the questions of a PI, you're fine. It doesn't matter if you're a PhD or a postdoc. And that's the thing. While a postdoc has more experience, you have a little bit more background. You know how things are going, and with the PhD, I don't think you think the same way. PhDs also can have a great idea. I'm like 100% sure, but maybe they don't do this thorough research and they do not have the exact background. Okay, maybe they know that they want to do this, but how and why, and is it possible?
It's a little bit more hopeful, wishful thinking. This would be cool versus this is actually something we can do in 2 years. Yeah, I think that's
Exactly.
a. Mhm.
Which doesn't mean that the idea is not good. Far from that. You can build upon it. Like if you bring it up in the meeting, maybe postdoc says something, then PI says something, then this and that, and you have a great idea. So I think the ideas are valued equally. It's just, ideas are also, the part of idea is how you execute it. If it's possible, if it's feasible, money-wise, time-wise, your objective-wise. So I think you have to take all of that into account. And I think postdocs do that more and are more ready, while PhDs might not be. Yeah, so that could be a difference.
Now, I definitely have noticed that I'm slowly shifting my mindset from how I used to generate ideas, which was mostly like, oh, this would be cool. And now more and more you're forced to integrate. Is it really doable? Like really doable? Can you actually do it in 2 years or a year? And what are the chances of succeeding? So cool. That's a good perspective. So now you're working on. I'm not sure I understand this correctly. So you work on circadian rhythms, and also you mentioned before we started the connection with obesity, lifestyle, but you also mentioned to me that you're working with organoids, which are basically just cell cultures, but try to imitate the 3D, right, of structure of the tissue. So maybe just tell me what exactly are you working on right now, and why is this exciting to you?
Yeah, well, I'm working on circadian rhythm. So basically, circadian rhythm is your body's timekeeping system. And most of the organisms, from bacteria to plants to humans, have their own timekeeping system. And the idea behind this timekeeping system is that they anticipate certain behaviors, actions, to help do it in the most optimal way. So, for example, if you have lunch constantly at 1 o'clock, at 12:45 you will start feeling hungry because your body is anticipating food around 1. And what that means is that your digestion will be better. And I mean, a lot of cognitive process, not just digestion, but you will be ready to receive this food and to extract the most nutrients, let's say, at 1 o'clock, because you have this is kind of your routine. But yeah, so what I'm working on is obesity, actually, in a relationship to circadian rhythm. So what does that have to do with anything? Apparently, not apparently, but you have certain cues, environmental cues, that are synchronizing or actually entraining your circadian rhythm. And the most important one is light. So day-night cycle is very important for maintaining your normal circadian rhythm. So in the morning, ideally, you wake up and you look at the sun or any dark clouds, whatever. You just need to see some lights from outside. And this is like a cue to your just specific part of your brain or hypothalamus that it's the day. And this like 24-hour cycle will kind of start. So during the day, normally we should eat, we should do activities. And then during the night, we should normally sleep, right? So your body is ready for sleeping, the digestion is slower, your rhythm is like adjusted for sleeping. However, there are instances where you had misalignment of these environmental cues and the rhythms that are happening in your body. So, for example, think about shift workers or jet lag. So, shift workers, they see the light, they see the day, and they go to bed. And then during the night, there is no light, but they eat. And for example, with the jet lag, you woke up, you saw the light, and now you're traveling, I don't know where, and the time is completely different there. And according to your home hours, you should be sleeping, but it's still day here. And you have this misalignment of these cues. The misalignments can cause a lot of metabolic disorders, can cause obesity even, can even play a role in cancer. And it has become a very hot topic ever since there was a Nobel Prize for the circadian rhythm studies, 2017, as I remember. So yeah, I'm working on obesity and circadian rhythm, and because I'm working in the gastrointestinal disorder lab, we're working on the gut. So we're working with the enteroids, which are organoids, basically from obese patients from the intestines. And why do we use organoids? They're very interesting. They're not like cell culture is like the cell lines are in 2D. Well, as you said, organoids are in 3D. They're embedded in some sort of matrix, and they grow 3D. And the most interesting part and the most useful part of this is that you have a mini gut in that 3D culture. So you have all the cells that you would find in your intestines, and therefore you can do your experiment and you will get, let's say, more faithful, let's say, results than you would get when you would have just one type of cells in 2D culture. However, they're very expensive organoids, and of course the technique for culturing them is quite different than for the cell culture.
So what kind of experiments do you actually do? Do you try to take an organoid and put it in an incubator that doesn't have the proper 12-12 cycle of light, keep it always in the dark, or make it confused? Or do you manipulate, like you put one cycle for 7 days and then different kind of cycle for 7 days and try to see the outcomes? Do you even manipulate, like what do you manipulate for these organoids? What do you try to see in the end?
Yes, I like the way you're thinking, but I think you're missing that crucial information. That is, organoids do not have a brain. You need to have a brain. The pacemaker is in the hypothalamus. It's in the brain. And organoids do not have a brain. They cannot see the light. They cannot sense the light. So with the organoids, you cannot actually do that. What I forgot to say is that you have one like a central clock in the hypothalamus, but you have a peripheral clocks. In every organ, in every cell of your body, you have certain clock. And these two clocks can also become uncoupled. And that is happening during the, for example, shift work and jet lag. That you have one signal that is entraining the hypothalamus, which is light, but then you start eating during the night, and your clocks, the peripheral ones from the liver, intestines, they're entrained by this feeding cue. So you have a misalignment of these clocks, and this misalignment is what is causing or what can be a part of these metabolic disorders, obesity, and so on. So with the organoids itself, we cannot really look at the light as a training factor, but what we can look at is feeding time, feeding stimuli. Interesting fact is that different nutrients entrain the clock differently. So, for example, high-fat diet can cause a disruption in your circadian rhythms.
What does that mean from the point of view of if I'm an organoid and you give me different cues, what do I align as a cell or as a cluster of cells? It's not like I'm waking up and then sleeping. What am I doing in that circadian fashion?
Well, if you were an organoid, which I don't think you would be. That was so funny. You're like trying to give cues as the right time and see what will happen with your rhythms, or if you give certain cues in different timings or different nutrients in different amounts, you see what will happen to your circadian rhythm. I mean, it's an interplay of certain clock genes, let's say, so you have an idea of a correct circadian rhythm. So you know that this one should be at this hour, this one should be at that hour, this one should be at that hour. So you can say, okay, like, now this is correct, great. But if I do something and this is misaligned, you have a problem in that way. I don't know if I explained this.
So if you give different cues at different time points, these genes are supposed to have a pattern, right? Which
exactly.
is, I guess,
24-hour matter.
Regardless of light in this case.
Yes, regardless of the light. Because we're working on the peripheral clocks. And peripheral clocks by themselves can be entrained by the feeding cues or different metabolites or yeah.
It's very interesting that I would expect the light to have some kind of, because if it's the most important thing in the brain, I would still expect if you would keep, same cues with feeding, let's say, but constant light versus constant darkness versus a normal circadian rhythm, that you might see some kind of differences. But let's.
But you can do that in mice. We do mice. We have mice that we jet lag. We keep them.
I'm just saying, like, I would expect it to be possible also in the cells, because if you take a look at, I believe bacteria also have their own circadian rhythms, right? Plants have their own circadian rhythms, so it's not necessarily, and it's also cued mostly to light. It's a very important factor, right? So at least in my intuition tells me that if you would mess up light patterns of the organoid, that the organoid would be unhappy in some way. But okay, so the main output is the genes, right? You look at the genes and how they are responding to these different cues of feeding. So you try to give them different diets, and you try to see how they respond circadially.
Yeah, and for example, how the obesity affects these. Because if you take the organoids from obese patients, chances are it's chroma disrupted. Chances are by itself it's chroma disrupted. So you don't have to, and then, you see if you can do something about it. And that is the thing that we're trying to do is, for example, what would be the regulations for the shift work? Because you have people that they sleep the entire day, then they go to work, and they, of course, they're tired, they're awake the entire night, they eat their meals during the night, and if you compare this kind of person, and this person, let's say, takes X amount of calories, and the person who eats during the day this X amount of calories, chances are the shift worker will be more obese and be more prone to metabolic disorders, cancer, even cardiovascular diseases. And that is the real problem. So it's not just about the calories. It is So there is something that is happening that, is influencing how these calories are used. That is affecting the obesity. And that I'm talking about obesity because I'm working on obesity, but there's like a number of diseases that are like that you have in hormone disruption. So it's not just about this. I recently read somewhere that when there's like a shift in time during the winter and the summer, and that when the clock goes backwards, so basically when you need to wake up 1 hour earlier because the time is also shifted.
There's more suicide.
Yeah. You on that day in particular, there are the most cardiac related like occurrences like heart attacks, strokes, and so on, and a lot of traffic accidents because you're disrupting the circadian rhythm of so many people. And some people are more like, I would say some people are more prone to these like
More
changes.
divorce requests, stuff like that. I would expect everyone to be going crazy in that time when they have to wake up 1 hour earlier than they're used
Yeah,
to.
definitely. Definitely. But yeah, it is very interesting. It is very complicated. Not much is known. And it's just interesting. And sometimes we're analyzing these rhythms in what we have and we're like, oh my God, what is this? Like it's so confusing. It's like also the questions like, okay, so if they're disrupted, how do I get them back to normal? And one of the strategies is time restricted feeding, where
Okay.
you restrict the time of the calorie intake or the food intake to the active phase. For humans, it means during the day. For mice, because they're nocturnal animals, it means during the night. So this helps. Even without any calorie restriction, it's been shown that the body weight of the obese, for example, mice, that it's going down if you restrict their calorie intake during the like nocturnal time. So it is very interesting, and it seems like this, who would have thought that, waking up at the same time, eating at the same time, of course, eating the right kind of things, of course, doing exercise during the day could be so beneficial for us. But just thinking about this and the kind of life that we're living now, it's really difficult because you are constantly under some artificial light, which will also entrain your central clock, master clock. So it's really difficult to, do these things. Also, for example, exercise. I think that the highest muscle strength, I think it's seen at 4 in the afternoon. And that is when I'm at work, for example. So what should I do? And I come home and I go to the gym during the night.
Do you mean the highest muscle strength is that there's a circadian element to actually your performance and exercise?
Yes.
Okay, so 4 p.m. would be like let's say, a good time to exercise because that's when you can most utilize your muscles. Is that what you're saying?
Exactly, but it also depends on your goals, which is another component. But yeah, circadian rhythm wise, it seems that the afternoons are the times when you have the most muscle strength.
That's very interesting. I mean, it feels like circadian. You went from one complicated topic in your PhD to an even more complicated topic that affects even more things and more people and more creatures on Earth. So I mentioned to you this study before we started recording about, how this group in Zurich from the Aceto lab was studying breast cancer patients, and they found these circulating tumor cells, basically the cells that are shed into the circulatory system, are mostly from the primary tumor, are mostly made during sleep, and they are most prone to metastasize, most powerful in metastasis, if you compare them to the cells that are shedding during the wake cycle. And this works also in mice, regardless of them being nocturnal. So the sleep is the factor that's actually affecting these cells. And I remember reading that study, for example, being blown away that circadian rhythm is profoundly affected. I think 95% of those circulating tumor cells were found to be made during sleep. And I remembered a very silly example that I brought up to my professor, who's a circadian biologist in Boston. And I remember, you know, those when you have like a mole in your skin, and sometimes it has a hair growing out of it. It's quite disgusting. I remember once I had a mole without a hair, and then I slept, and I woke up, and then the next morning there was like two giant hairs popping out of it. So I'm wondering, ever since that day, which was very silly, I'm wondering what kind of an effect sleep could have had, or generally circadian rhythm could have had on proliferation of cells. Like it's a very interesting and profound topic. So, what have you had any? I guess this is a recent position for you that you started in Leuven. Looks like you've been there for a super long time, but have you already made any conclusions about or any discoveries about how these cues can affect organoids and how that fits into the bigger picture of circadian rhythms and how it affects obesity?
Um, yeah, I mean, I'm not at liberty to discuss the most
Oh, okay.
recent
Sorry, I'm not gonna.
data, but indeed, what I'm trying to tell you is that, okay, we're using organoids, but we're not we are trying to extrapolate everything that we find from the organoids to the people that are frequently traveling, that are doing the shift work, and then have some sort of disorder, in our case obesity, because we could get the organoids from obese patients the easiest, so right now what I can say is that we see that time restricted feeding is beneficial for the entrainment, but this is nothing new. It's already been there. So time restricted feeding means you have a window where you're eating, and ideally it's during the active phase, during the light, and this window should be around 8 hours. So even without calorie restriction at all, there are still benefits, and there are health benefits and improvements that you can see just by restricting your eating time in this time window. And now, with calorie restriction, it's another story. I mean, of course, calorie restriction will most likely help you lose weight, right? Combined with exercise and so on. There are so many factors, but the factor of just timing of the eating is very big one. So I would suggest everyone, if you can, to restrict your eating during the active phase and to get good night's sleep when it's dark, not to stay playing games for too long or looking at Netflix. But we all do that. That's what I'm saying. I sometimes feel like we're just researching what has already been known for years. I mean, the older ways of life. Yeah, you should walk 10,000 steps per day. Of course, you should walk 10,000 steps per day. It's not normal to be sitting for 10 hours. You should not stay up too late. Of course, I shouldn't. There is night for a reason, but we're looking at the shows. You should eat during the day. Of course. I mean, this is also logical, but now we're discovering why it is logical and what kind of an impact it has. I also forgot to say that the circadian rhythms have a lot of impact on mental disorders, for example, depression. So, yeah, worth giving a try.
Yeah, as much as someone might be a proponent of adventurous life, the more I live, and it's getting more and more every day, it seems to me that we are truly creatures of habits, and it seems really good for the mental health, at least I've noticed in myself, to have a very strict schedule of waking up, eating at a particular time, if you can, exercising at the same time, sleeping at the same time. It might seem a little boring or a lot boring, depending who you are. But I've definitely noticed that when that is implemented in my life, that 1 week is the best week I have that month. So yeah, I definitely agree, and especially with the waking and sleeping. I've recently implemented to sleep a little bit earlier than I usually do, because I feel like I always slept very late, 12, 1, 2, and then I wake up at 5, very disturbed sleep-wake cycle. And then recently I started sleeping at 10, 10:30. And it was just a nice shift, last night coming back from the city at 10, and I'm like, oh, I could actually go and get some good night's sleep. That would be very nice now at 10:30 rather than watching The Big Bang Theory once again. So Hana, it's been quite a long time. I'm sorry if we didn't cover everything we wanted to talk about, but I'm noticing my concentration slowly deteriorating. So I would like to wrap it up slowly and go to the last phase of this conversation. So maybe tell me, what is next for you? What are you doing these days? What are the plans for the future? What's happening in your life that's nice and important?
Yeah, well, currently, I mean, I have just started working as a postdoc. It hasn't been even 6 months, I would say. So I'm still, in that phase, adapting to being a postdoc and adapting to a new country because I also recently moved here. So actually, everything is quite new for me. But if you're talking about, far, far, not so far future, actually, um, I think that I will eventually, most probably, shift from academia to industry because, there are upsides and there are downsides of academia. But I somehow, because I was in academia my entire career, let's say, I feel like that certain skill set that I have would be more beneficial in industry rather than in academia, or that is at least how I see it for now. But this is the plan for future years and so on, which would also, help me maybe stay in one place with, potentially having larger families and so on. But yeah, I think I will forever be in love with science, and hopefully, in the next period, I will also try to make my another dream come true, and that is, let's say, open or start a coaching business for people that are struggling like I did. With weight, with brain fog, or with even just, losing direction, not knowing where to go further. Because I feel like the more I'm learning about this circadian rhythm fitness industry, the more knowledge I have to give. And I've already kind of, let's say, helped a couple of friends just by talking today, and it has switched their life according to them, So I don't want to gatekeep that for myself. So indeed, if any of the listeners want to talk to me, I would be more than willing to answer your questions. You can always reach out to me on LinkedIn, or if you just want to say hello or to chat about your PhD and your struggles, I'm your girl. I understand you. So yeah, that's pretty much it.
Awesome. So for those who want to go follow you or reach out to you, connect with you, I guess the best place would be on your LinkedIn profile, just Hana Sahinbegovic. And is there anywhere else there where people should follow you? Where can they find you?
Yeah, I think the LinkedIn would be the main face for now, but yeah, follow LinkedIn for whatever else is to come.
Awesome. All right, Hana. Well, I'm happy that you have some plans that are a little different than just academia, because that sets ground for another conversation, which I would definitely love to have again with you. And thank you very much for your time and sharing all of this experience over these almost 2 hours.
Thank you so much for having me. It was a pleasure, and I hope to talk to you soon.
All right. Awesome, Hana. Thanks, everybody.